one-way ANOVA followed by post hoc test in both Excel and SPSS. One-way ANOVA followed by post hoc test in Excel. One-way ANOVA statistical test is a test used to compare between several variables that are normally distributed and fulfill the assumptions for doing the test. Post hoc test is another test that will determine which pair of variables or groups are different and have statistical differences in their mean. Here in Excel, I had inserted data for 4 different groups of individuals with their occupations: doctor, dentist, pharmacist, and nurses. 25 cases for each individual group, and the salary or the earning for each doctor per year is inserted here, and we want to compare between the salary for all these 4 groups. So the salary here is the dependent variable and the grouping is the independent variables, which is the occupations. And to do one-way ANOVA analysis to look for any differences between all these four groups, click on data, then click on data analysis here, and if you don't have the icon for the data analysis, there is a way to insert and place that data analysis in Excel by clicking on file, click on more, and then click on options, click on add ins, then click on go, and this window will appear. Tick this if it was unticked, analysis tool pack, and then click on OK. So to do one-way ANOVA, click on data analysis, a window appear here, and we're going to select the analysis tool for ANOVA single factor. Click on OK, a window will appear here, and we are going to input the range for the data, and we're going to select these data as shown here, and I'm going to tick the labels in the first row, and I'm going to keep the alpha p-value for 0.05, and I'm going to generate the output range in this cell here. And if I click on OK, a table is generated for ANOVA, showing first descriptive, a summary, and then ANOVA table. In the summary here, we can see that there are 4 groups: doctor, dentist, pharmacist, and nurse. And there are 25 participants in those, or members of this, each group. And the average for the salary here is variables between the groups. We can see here that the doctors have the highest salaries and the nurse are the lowest. And then if we look at the variances here, we can see that they are nearly close to each other or similar. So this here indicates that there might be a homogeneity of variances. For doing ANOVA, you need to satisfy one of the assumptions, which is homogeneity of variance. And to check whether your data follow that homogeneity of variance, there is a certain way to do that, and I will produce that in a separate video. But at this stage, we will move ahead with the analysis of ANOVA. In the next table, ANOVA, labeled as ANOVA, shows that there is a if we click enlarge this one, it says that between groups, and as we can see here, an F test is performed and a value is generated, and p-value here is less than 0.05, which means that this test shows that there is a significant differences when we compare all the four groups based on their salaries, but this test does not specify which pair of groups that are significant. So once the ANOVA analysis is performed, the next step is to perform post hoc test. So there is no straightforward post hoc test that will compare all the possible combination between all these four groups, and we have to do that pair by pair using a t-test. So if I want to compare the group for doctor with dentist and find out whether there is a significant differences in those two groups, and then compare the doctor to pharmacist, doctor to nurses, and then dentist to pharmacist, and dentist to nurses, and then pharmacist or pharmacist to nurses. So we're going just to show here how to do a couple. If we want to compare the two groups here, doctor and dentist, again click on data analysis, scroll down to t-test to sample assuming equal variances. Here we need to assume that there is equal variances, and I've already done that, and I checked and I found that these data have homogeneity of variance. So I'm going to select that, and I'm going to select the range of the data for variable 1. For variable 1, I'm going to click on the first row here and click on Control Shift Hold to select the whole column, and then for variable 2, click on dentist, Control Shift Hold the arrow down key, and then click on the labels here, tick on the labels, and I'm going to generate the output in that area here in this place, which is indicated here. And then if I click on OK, a new table is generated for t-test comparing the two groups, doctor and dentist, showing the mean. As we can see here, there is a difference in the mean, 101 compared to 101,000 compared to 60,000, and the variance here is also given. And for the value, it's gave here p-value for one-tailed and p-value for two-tailed, and as we can see here, there is a significant differences between those two groups. So that's mean dentist has a lower salary compared to doctor, and doctor have the higher salary. And if we intend to do also comparison between doctors and pharmacies, we'll repeat the same thing. Click on data analysis, select two sample assuming equal variancing, click on OK. Then in this window, select the first variable range, which is already selected for doctors, and then for the second one, we're going to select the pharmacist. Click on Control Shift and keep holding it, and click on the down arrow key. Click on this, tick on this labels, and then select the output range and insert the output range here in this place. Let's keep it in this area, and then click on OK. A table is generated here for comparing the doctor with the pharmacist, and from that table we can see that there is a difference in the mean between doctor and pharmacist. Doctor have higher salaries compared to pharmacist, and there is nearly similarity in the variance. And for two-tailed test here, we can see the p-value is very significant, as it is less than 0.05. This is the way to do one-way ANOVA for multiple group of data in Excel and follow that by post hoc test based on t-test. One-way ANOVA in SPSS followed by post hoc tests. One-way ANOVA is one of the statistical tests that is performed to compare between groups and look at differences between means. It is used when that number of groups is equal to 2 or more, but it's more commonly used for 3 groups and more. So the ANOVA will look at the differences between the groups and determine whether there is a significant differences between the groups. Here in this SPSS data viewer had inserted 100 cases for individuals. One of the variable here is labeled as job, showing 4 different categories of professions: doctors, dentist, pharmacist, and nurse. And each one of them has been coded for 0 for a doctor, and 1 for dentist, and 2 for pharmacy, and 3 for nurse. For a second variable is the salary, which shows how much those individuals earn annually for doctors, for pharmacist and dentist and nurse. Again, there is variation on those salary range between doctors, dentists, and pharmacists and nurses. And here I have 25 participant or 25 cases of doctors and similar dentists, pharmacists, and nurses. And in a third variable I had inserted saving, how many saving those individuals managed to keep at their bank after working for at least 10 years, and the salary is, as I said, measured annually. So to compare between those individuals, the 4 groups, and to find whether there is a significant differences between the salaries, we're going to use ANOVA to do that. ANOVA in SPSS can be performed in 2 different ways. The first one is through clicking on Analyze, then scrolling down to Compare Means, and then to One-Way ANOVA. Click on that, and then a window will appear. I'm going to reset that. In this window, I'm going to move the factor, which is the group job, into the factor space, and then I'm going to move the salary to the dependent list. And I'm going to select options, click on descriptive, homogeneity of variance, and I will include Brown, Forsyth test, and Welch test, and also will plot the means. Click on continue, and for post hoc, since we presume that there is equal variances, I'm going to stick to key. Tick that box and then click on continue. If you click on OK, output is generated. In the first table, descriptive shows the salary for all the 4 professions, and there are 25 individuals in each profession, and the mean for each occupation is inserted here. And as we can see, there is a difference between the salaries for those individuals. However, in the standard deviation, we can notice that the standard deviation for each group is very close. So that's also given insight that there is homogeneity of variance. And one of the assumptions for ANOVA that has to be met, it should be a homogeneity of variance, and that is given in the next table. It shows that there is a homogeneity of variances between those four groups of individuals. The third table is the ANOVA table, which shows that there is a difference between the four groups, as it is measured by a test called F test, and a significant value of less than 0.05. So the ANOVA table here shows that there is a significant differences between the four groups, but it doesn't, the ANOVA does not specify which bears what combination of professions that they have the differences. For the next table, which is robust test of equality of mean using Welch and Brown Forsyth test, again this is irrelevant here, as there was a homogeneity of variances and the assumption has been met for ANOVA, so we're going to exclude this from the analysis for this set of data. And then another table is generated for the comparison, which is the multiple comparison between each group to find possible combination, all the possible combination comparison between groups to find out which combination has a statistical significance in the salary for the participant. Again, as we can see, comparing doctor with dentist, there is a significant differences in the salary between doctor and dentist, doctor and pharmacist, doctor and nurse, as the p-value was less than 0.05. So these data shows that there is a significant, based on the ANOVA table here, there is a significant difference between the groups. And then the test we chose here, Toki test, determine which pairs or which two groups shows differences. Again, here we can see all the groups have differences in the salary range. The final graph shows the mean for the salary for all the four occupations is decreasing. The doctors has the highest salary and the nurse the lowest salary. So this test shows that there is a differences between the four different groups. So this is one of the way to do ANOVA. Another way is to click on Analyze and then scroll down to General Linear Model and then click on Univariate, reset that, and I'm going to move the job to the fixed factor and the salary to the dependent variable. And in the plot, I'm going not to select anything at this stage. In the post hoc, again, I am going to move this job into the post hoc test for the jobs, and I'm going to take the 2 key when there is an equal variance assumed, as we can assume now. I've double checked that there is an equal variance. Click on continue for EM, and I'm going to move this into the click on it and move it into display, and I'm going to compare the mean differences as selected here. Click on continue. In the save options, I'm going to take and standardize predict variable values. Click on continue. In the options, I'm going to take in descriptive statistic homogeneity of test, which is Leven's test, and also estimate of the effect size. click on continue, and then if I click on OK, the univariate analysis output is somehow similar to what we have done in the previous one-way ANOVA. It shows here the first table between subject that we have doctors, there are 25, and similar to dentists, pharmacists, and nurses. The second table is descriptive statistics, shows that the mean for each individual salary for each profession is different. However, standard deviation is nearly similar for all the 4 professions. These data are not different from the previous analysis we've just done. And for the test of variances, homogeneity of variances, here we can see this table shows that the variance is homogeneous between all the 4 groups, and the value here as given by the significant value, which is greater than 0.05. Again, for the this test generate between subject effects, and it has a F ratio and significant, and we are here interested on the job. Shows that there is a significant differences between occupation in terms of the salary. A partial test shows the effect size, which is high here. Again, another table is generated, Toki test, showing the difference between the means and the significant value. All the possible combination between pairs of professions and the significant. There is a significant difference between all 4 occupations. And finally, as shown here by Toki HSD, and that's basically how the ANOVA test is performed in SPSS. Now I have also inserted here another variable, which is the saving, and I'm going to do an analysis on this saving variables to look at whether there is a significant difference between occupations, the 4 different occupations, and saving. So again, I'm going to use analyze, click on analyze, compare means, then select one-way ANOVA, and I'm going to remove the salary and insert saving, and then keep all the setting the same. Click on OK. Again, a descriptive table is generated showing all the 4 occupations with the sample size for each variable, and the mean. As we can see here, there is a variation in the mean, and so there is a difference between the groups. However, the standard deviation does vary here, varies, as we can see, so thus indicate a heterogeneity on variance. Again, testing for homogeneity of variances indicate that these 4 groups are heterogeneous. So this is in terms of variances, so this assumption has been violated for ANOVA. Thus, this table ANOVA cannot be used for interpretation, and the F factor here, we have to go and instead use the Welch and Brown's Forsyth test for comparing between the groups, as it's robust. It shows here that there is a significant differences between the groups, which is both of them nearly less than 0.05. Since there is a violation of homogeneity of variance, then this table need to be reported instead of the ANOVA. And to look at the comparison between all possible combination of groups, then we are here going to select Since there is no homogeneity, we have to visit this again. We need to select the post hoc here, since we know that there is unequal variances. Then we will untick this and then take the game howls for unequal variances and click on continue. And as we can see here, the game's howl is generated and shows that there is a significant difference between all possible combinations of professions. And graph here plotting the mean shows that the saving is the highest for doctors and it's lowest for the nurse. So this is the way to do ANOVA in SPSS when you have homogeneity of variances met, or when the homogeneity of variances is violated.